Today, you are going to learn exactly how to teach AI entirely new customized tasks using a really standardized, lightweight format called agent skills, or specifically the skill.md specification.
Yeah, because we are finally moving away from just typing, endless desperate prompts into a chat box and hoping the AI remembers what to do by paragraph 4.
Right. I mean, we'll uncover how to actually build these physical playbooks for AI, the incredibly strict rules for their folders, and this completely ingenious menu versus cookbook method that AI uses to save its own memory while reading them.
It's honestly a massive shift in how we interact with these models. This is about giving artificial intelligence actual repeatable domain expertise that it can carry across any compatible platform.
And as someone who spends like a ton of time trying to get AI to format data or draft specific emails and just getting so frustrated when it starts hallucinating halfway through, I am fascinated by how this works under the hood.
Well, to understand the architecture of an agent skill, you absolutely do not need a computer science degree.
Thank goodness.
Right. This standard was originally developed by Anthropic. They released it as an open standard, and now it's being adopted everywhere. And at its fundamental core, an agent skill is essentially just a portable directory.
Okay, so a folder.
Just a folder, a totally self-contained package.
Let's try to ground this in a real-world scenario. Imagine you are hiring a brand new employee. They're brilliant, they process info incredibly fast, but they know absolutely zero about how your specific business operates.
Exactly. You wouldn't just verbally yell a list of 60 instructions at them as they walk through the door, right?
No. You would hand them a comprehensive dossier, like a physical playbook.
And in this digital ecosystem, that playbook is your agent skill directory. The name of the folder is the label on the tab. When the AI opens that folder, the very first thing it looks for is a mandatory file called skill.md.
So that skill.md file is the printed set of instructions sitting right on top. And reading the specification, it makes it super clear that this file is non-negotiable.
Oh, completely. If it's missing, the AI just doesn't know what to do. It throws its hands up.
But if that main file just contains text instructions, what happens when the AI actually needs to do something outside of just chatting? Like, if I want it to pull live data from a website or crunch numbers in a giant spreadsheet, where does it keep its actual tools?
That is where the directory structure becomes so powerful. Behind that main skill.md document, you can include these specific optional subfolders to give the AI everything it needs.
Okay, what kind of subfolders?
The first really common one developers use is the scripts folder. This is dedicated entirely to executable code runtimes.
When you say executable code runtimes, for someone who isn't a developer, what exactly are we putting in there?
You're putting in actual runnable code. Think Python scripts or Bash scripts, which are basically just command line instructions you'd normally type into a terminal to move files around or automate tasks in the background.
Oh, I see.
Yeah, so if your AI needs to actually run a complex math calculation or securely scrape a specific database, the code to perform those actions lives right here in the scripts folder.
So we have active functional tools in the scripts folder. What else can we put in this manila folder?
Next is the references folder, and this is for detailed deep dive documentation.
Like what?
Let's say you are building a skill for legal contract review. You really do not want to cram an entire textbook of European compliance law into your main set of instructions. It's just too messy.
Right. That would be a nightmare to read.
Exactly. So you put supplementary documents like a finance.md or a legal.md file into the references folder. It's also where you'd store structural templates, like a file that shows the AI exactly how the final output report should look.
Okay, got it. So the main skill.md file basically says, review this contract, and then adds, if you need to know the specific laws, go read the file in the references folder.
Precisely. It keeps the main instructions super clean. And then the third subfolder you can use is the assets folder. This is strictly for static resources.
Static resources like images and stuff.
Yeah, if your AI needs to reference a static diagram, a logo image, or a massive lookup table of data schemas, that all gets safely tucked away in the assets folder.
Okay, but looking at this whole package, we've essentially handed our brilliant new AI employee a heavy directory stuffed with Python scripts, complex legal documents, and dense data tables.
Yeah, it's a lot of material.
Which creates a very obvious problem. If the AI is holding all these scripts and references, how does it not get completely overwhelmed trying to read them all at once? I mean, if I hand a human a 500-page dossier, they're going to freeze.
And that is literally the defining challenge of AI right now. Every time you feed an AI information, It takes up space in what we call its context window.
The short-term memory.
Exactly. You can think of the context window as the AI's short-term working memory. If you stuff too much into that short-term memory, the AI starts dropping things, forgetting rules, and hallucinating entirely.
So how does the playbook fix that?
The agent skill specification solves this right at the top of the skill.md file. The AI actually does not read the whole folder right away.
It relies on a set of metadata to decide if it even needs to open the folder in the first place, right?
Yeah.
Which brings us to the Frontmatter.
Yes, the Frontmatter.
So if the directories are playbook, the Frontmatter is basically the highly detailed sticky note slapped on the outside cover. It tells the AI exactly what is inside without forcing it to read a single page of the actual instructions.
In technical terms, it's a YAML metadata block at the very top of the file.
YAML.
Yeah, YAML stands for YAML in markup language. It's essentially just a way to format data so that both humans and machines can read it easily, using simple line breaks and indentation instead of confusing brackets or tags.
Oh, nice.
But the rules for this specific YAML sticky note are incredibly rigid. The very first thing required is the name field.
The label on the folder tab. And the specification dictates that this name field is strictly limited to 64 characters.
Yep.
Furthermore, you can only use lowercase letters, numbers, and hyphens. No capital letters whatsoever, no spaces, no underscores. You cannot have consecutive hyphens, and the name cannot start or end with a hyphen.
It is remarkably strict.
And this 64-character name has to perfectly match the name of the parent folder holding all your files.
And if it doesn't match perfectly, or if you use even a single capital letter, the entire skill will just fail to load.
Okay, wait, I have to push back on this.
I know what you're going to say.
We are talking about cutting-edge generative AI that can pass the bar exam and write symphonies in seconds. Why on earth are we forcing human developers to adapt to a 1980s-style lowercase-only filing system? Isn't the AI smart enough to figure out a capital letter or an underscore?
It sounds completely archaic, I totally agree. But you have to separate the AI's brain from the actual plumbing that the files travel through.
What do you mean by plumbing?
These agent skills are designed to be universally portable. So they might be created on a Windows machine, zipped up, hosted on an Amazon Linux server, and then finally downloaded by a completely different operating system on a mobile edge device.
Ah, so it's an operating system issue, not an AI issue.
Exactly. Different operating systems handle spaces and capitalization differently. A space in a file path can break a URL when the AI tries to download the skill. An underscore might be interpreted weirdly by certain command line tools.
Oh, wow. I didn't realize that.
Yeah, so by forcing everyone to use lowercase alphanumeric characters and single hyphens, which is a format known as Kebab case, by the way, the specification ensures the file paths remain completely bulletproof and predictable, no matter what machine is opening the cabinet.
Okay, that makes complete sense. We are basically baby-proofing the file system so the genius AI doesn't trip on the stairs.
That's a perfect way to put it.
So below that rigid name field on our sticky note, we find what is arguably the most critical piece of the Frontmatter, which is the description field.
The description field is the absolute engine of the whole system. It's limited to a maximum of 1,024 characters. And this isn't just a polite summary for human developers to read. This is the literal trigger text.
The trigger text. So when the AI is sitting idle, this description is the only thing it reads to determine if it should activate your skill.
Exactly.
And reading through the documentation, what's really fascinating to me is that a good description has to explicitly detail not just what the skill does, but when the AI should use it. You have to design specific conversational triggers.
Right, because the AI is constantly evaluating user requests, right? If you write a lazy description that just says, analyzes data, the AI is either going to ignore it or worse, trigger it every single time someone asks a simple math question.
Which would be super annoying.
Totally. A well-written description needs to say, use this skill when the user asks to analyze quarterly financial data. It expects CSV files as input and will output a formatted Markdown table. You are giving the AI the exact context it needs to grab this specific folder out of a massive lineup.
It's basically the elevator pitch to the AI. You have 1,024 characters to sell the agent on why it needs your tools for this current task.
That's exactly what it is.
Now, there are some optional fields on this sticky note, too. What else can we put in the YAML block?
Well, you have a license field, which simply states the copyright or open source license. But much more importantly, you have the compatibility field, which is capped at 500 characters.
And what does that do?
This is crucial. if your skill has specific environmental dependencies.
What kind of dependencies? Can you give an example of that?
Sure. So let's say your skill relies on a Python script to scrape a website, but the actual machine running the AI doesn't have Python installed. If the AI opens the folder and tries to run the script, the whole system just crashes.
Right, it would just break.
Exactly. So by using the compatibility field, you can explicitly state, this skill requires Python 3.9. The AI reads that on the sticky note, checks its current system, and if it doesn't have Python, it knows instantly that it cannot run the skill.
Oh, so it prevents a catastrophic failure mid-task.
Yep, it reads the requirements on the cover before committing to the job.
It stops the AI from making promises it can't keep. That is brilliant. And you also have an open metadata field for custom key value pairs, maybe tagging it with an internal department code for your company, and an experimental allowed tools field.
Yeah, that one creates a space-separated list of pre-approved tools the skill is authorized to use.
Awesome. So that wraps up the Frontmatter. That is everything the AI sees from the outside of the folder.
Correct.
So we have our folder and we have our rigid but clearly necessary sticky note on the front. We are just about to actually open this file up, read the instructions inside, and reveal the brilliant way AI manages its memory while executing them. But before we dive into the actual body of the playbook, I want to take a brief moment.
Take your time.
If you are enjoying this audio breakdown and finding these tech deep dives helpful to your workflow, please take a second right now to subscribe and like this deep dive. It really, really helps us keep bringing you these step-by-step explorations.
It really does. So back to the playbook. The AI has read the sticky note. The 1024-character description perfectly matched the user's request, and now the AI decides it's time to actually open the folder and read the document.
The Markdown body. The real meat of the SKILL.md file. This is just plain text, and it's where the magic actually happens.
This is where you write out your procedural workflows, your step-by-step instructions, and examples of good inputs versus bad inputs.
And it's also where you put negative constraints.
Oh, negative constraints are so important. It's often way harder for an AI to know what not to do.
Yes. Anyone who has used AI knows it just loves to over-explain things. So in this body text, you explicitly write things like, do not format the final report in bold, or do not include an introductory summary, just give me the data.
Exactly. You have to be firm.
Now, while there aren't strict syntax limits here like there are in the YAML block, there are strong official recommendations. The specification advises keeping this core file under 500 lines and strictly under 5,000 tokens.
Which is a really crucial limitation for performance.
Let's translate that for a second because I hear tokens thrown around constantly in AI discussions. What does 5,000 tokens actually mean for the person trying to write this playbook?
A token is basically the fundamental unit an AI uses to process text. It doesn't read words the way you or I do. It reads chunks of characters.
Oh, okay.
A good rule of thumb is that a token is roughly 3/4 of a standard English word. So 5,000 tokens translates to roughly 3,500 words. Think of it as about 10 to 12 pages of a printed book.
Okay, so a 10-page instruction manual.
Yeah.
Which brings us right back to that problem of the AI's short-term memory, the context window. Even if it's only 10 pages, if the AI has 50 of these folders available, it's going to get totally overwhelmed.
Definitely.
This is where the core architectural magic of agent skills comes into play. It's a concept called progressive disclosure, and I really like to think of this as the restaurant menu versus the cookbook method.
It is, without a doubt, the most elegant way to manage context windows I've ever seen in a framework like this.
Let's break down how this works in 3 stages. Stage 1 is the discovery stage. Imagine the AI agent walking into a massive library of restaurants. At startup, the AI does not read the thick cookbooks. It only reads the menus in the window.
And in our case, the menu is just that tiny 124-character description on the YAML sticky note.
Exactly.
Because it's only reading those tiny descriptions, the memory footprint is basically 0. An AI agent could have a library of 500 different skills loaded up on standby, and it wouldn't slow down its processing speed or burn through expensive cloud compute resources at all, because it's only holding those tiny menus in its active memory.
That is so smart. Then we hit stage 2, which is the activation stage. So the user asks the AI to review a legal contract. The AI scans its 500 menus, sees the legal review skill description, and realizes, aha, this is the one.
Yep.
Only at that exact moment does it actually open the folder and pull out the thick cookbook.
It loads that 5,000 token markdown body into its context window. It reads the 10 pages of step-by-step instructions. But crucially, it still hasn't loaded any of the massive files sitting in the subfolders yet.
Which leads us nicely to stage 3, the execution stage. The AI is now in the kitchen. It is actively cooking the meal based on the cookbook. As it goes through the steps, it might reach a line that says, run the compliance checker.
Right.
Only at that exact specific moment does it reach into the scripts folder and execute the Python file. Or, if step 4 says, format according to European law, it reaches into the references folder and reads the legal.md document.
It pulls heavy resources only on demand. This 3-stage process, discovery, activation, and execution, is the entire reason the specification works so incredibly well.
Because it paces the AI.
Exactly. If you shove 10 pages of instructions, 5 Python scripts, and 3 legal textbooks into a single chat prompt, the AI's context window would completely max out. It would hallucinate, it would forget step 2 by the time it reached step 5, and honestly, the compute cost would be astronomical.
It's just a total mess.
Yeah. Progressive disclosure keeps the AI focused entirely on the very specific step right in front of it.
It is a brilliant way to bypass the hardware limitations of current AI models. So we've built our directory, we've written our 64-character lowercase sticky note, we've filled the Markdown body with our cookbook constraints, and we've set up our subfolders to trigger only on demand.
We're almost there.
Right, because the final step is assembly and validation. How do developers make sure this whole package actually works before handing it over to the AI?
Well, there are a few physical limits and structural constraints you have to respect when you're boxing this all up into a zip archive for distribution. First, when you are writing your main cookbook and you want to reference one of your subfolders, you absolutely must use what are called relative paths.
Meaning, instead of pointing to a hard drive location on your specific computer like C:/user/document/my_skill/references, you just tell the AI, look in the references folder right next to this file.
Precisely. If you hardcode your computer's specific file path, the skill will instantly break the second someone else downloads it on their machine. It has to be strictly portable.
Got it.
Furthermore, the specification strongly recommends keeping your references just one level deep.
Wait, what does that mean?
It means do not create deeply nested folders inside of other folders. Like, don't do references/legal/2026/Europe/compliance.md.
Oh, right. That sounds confusing even for me.
It is a guaranteed way to confuse an agent trying to navigate a file tree. Keep it flat. Keep it simple.
And what about the actual size of the zip file? We have all these subfolders and assets. There have to be limits to the size of the briefcase we are handing the AI, right?
Absolutely. When you are bundling this folder to share it or upload it to an agent platform, there are hard physical constraints to keep the platform stable. You want to ensure the AI can download the skill rapidly over a network?
Right. You don't want it waiting 10 minutes to download a file.
Exactly. So the entire zip archive must be under 50 megabytes in total. You are allowed a maximum of 500 individual files inside the folder, and no single file can be larger than 25 megabytes.
So definitely no dropping massive 4K video files or gigabytes of raw data into the assets folder.
Right. This is meant to be a lightweight procedural playbook, not a massive media hard drive.
Okay, that makes sense.
But once you have all your files assembled and you're well under those size limits, you don't just blindly upload it and hope you didn't make a typo. You use a command line tool provided alongside the specification. It's called skills-ref-validate.
Oh, I really appreciate tools like this. It's essentially an automated spell checker and structural proofreader.
It acts as a strict gatekeeper. You run your agent skill folder through this validator, and it automatically checks everything we've just discussed today.
Oh, wow. Everything.
Everything. It ensures your YAML Frontmatter is formatted perfectly. It checks that your folder name exactly matches the 64-character naming rules without any forbidden capital letters or spaces. It ensures your file size is under 50 megabytes.
It's the restaurant manager doing a final rigorous walkthrough, checking the menus for typos and making sure the kitchen is properly stocked before actually opening the doors to the public.
It's a great analogy.
If that validator gives you the green light, you know with absolute certainty that your playbook is structurally sound and ready for any compatible AI to pick up and use.
And that compatibility is really what makes this open standard so revolutionary. A skill you carefully design and validate today for one AI interface can be picked up, unzipped, and perfectly executed by a completely different AI tool tomorrow.
It's amazing. Let's recap the journey we just took. We started with the goal of giving AI permanent, repeatable domain expertise. We built a digital directory. We labeled it with an incredibly strict YAML Frontmatter block navigating the cross-platform constraints of a 64-character lowercase name. So the AI knows exactly what the skill is and when to trigger it. Then, we filled the plain text Markdown body with detailed workflow constraints and token limits. And we used the menu versus cookbook strategy of progressive disclosure to ensure the AI saves memory, only pulling up subfolder scripts and references right when it needs them.
Yep, keeping it efficient.
We kept our files flat, stayed under our 50 megabyte limit, and ran it all through the validator.
It's a highly efficient, entirely portable unit of knowledge. And when you look at the broader implications, it honestly raises a truly fascinating question about the future of automation. The specification explicitly highlights the goal of cross-product reuse.
Meaning these agent skills aren't locked into walled gardens. They are universally portable across platforms.
Exactly. So think about what happens when community developers all over the world create thousands or even millions of these standardized playbooks. You won't just be teaching your own personal AI a few neat tricks.
What does that ecosystem look like?
Well, it leads to the possibility of a future AI autonomously acting as a general manager. Imagine an AI that isn't just following your single playbook, but is dynamically browsing an endless open-source library of these menus on its own.
Wait, really?
Yeah, you give it a massive, vaguely defined goal, and without human intervention, it seamlessly chains together a data scraping skill it found from one developer, a legal review skill from another, and a presentation formatting skill from a third.
Oh my goodness.
It could accomplish massive multi-step jobs that we haven't even explicitly programmed it to do yet, simply by reading the right sticky notes and opening the right folders.
It's incredible to think about. We aren't just teaching an AI how to do a single job. We are essentially forging the standardized Lego bricks of artificial intelligence behavior. You hand the AI a perfectly organized directory today, and tomorrow it just might build an entire autonomous ecosystem. That is definitely something to think about the next time you find yourself typing the same prompt for the 100th time.